Good morning from Walter and I. So today we are going to look at potential energy, guys. Let me pause this so I can get the dog off the couch because he is not supposed to be on the couch. I'll be back. So I had to switch the scenery just a little bit because my computer is dying. But let's jump into potential energy. So we know that potential energy is energy that is stored as a result of position or shape. So let's think about the guy in our picture right there. He's shooting a bow and arrow. So as he is shooting that bow and arrow, he is pulling back that string. That string has some type of potential energy. And as soon as he releases it, it becomes kinetic energy. Same thing if we had a picture frame, right? And we put it up into the air and we're holding it there. When we go to drop that potential energy is going to turn into kinetic energy. As we move this picture up, we're having more potential energy, and then when we release it, it turns into kinetic energy. So there are two different ones that we're going to talk about: gravitational potential energy and elastic potential energy. So let's move on to the next slide and let's talk about gravitational potential energy. So we see this girl up on a diving board. And what had to happen in order for her to get up to that diving board is she had to climb up these steps. As she was climbing up those steps, she was building her potential energy. You might ask, why is she building it? Well, let's look at the first bulletin point. It says potential energy depends upon an object's height. So as we get higher, our potential energy is going to increase. So if we were in the low dive compared to the high dive, clearly we're going to have more potential energy when we hit that high dive. When we look at gravitational potential energy, we're going to look at the mass, the acceleration of gravity, and then we're going to look at the height. So our formula is going to be mass times gravity times the height. And here, when we look at gravity, it's going to be 9.8 meters per second squared. So I wanted to give you guys a little bit of an example using Walter as our example. So we have a step right here. Walter is going to get up here. As he walks up here, stand still, he's going to have more potential energy. But as we increase Walter and we lift him up, he's going to get even more potential energy. Then we drop him, just kidding, he's going to gain kinetic energy. So guys, hopefully that gives you a little bit of idea about the gravitational potential energy. Next, what we're going to move on to is going to be elastic potential energy. So I kind of forgot. Right before we move on to elastic potential energy, let's do a practice problem real quick. So a diver at the top of a 10-meter high diving platform has a mass of 50 kilograms. What is the potential energy? So let's pause the video, and I want you to try this one on your own before you actually get my answer. Don't cheat. Make sure you pause it. So once you get back from this practice problem, you should have on a piece of paper that it's 10 times 9.8 times 50, and your answer should be 4,900 joules. Hopefully you got that one correct. So let's move on. Elastic potential energy is the potential energy of an object that is stretched or compressed. So think about when you were little, and well, maybe some of you actually still do this, and you took rubber bands and you stretched them out and you could see how far they went. As you were pulling those strings back, what was happening is you were gaining potential energy of that rubber band. And then when you released it, boing, there it went. You got kinetic energy. Actually, let me give you some examples of what I can use in my house to show you elastic potential energy. Let me pause the video. All right, Me and Walter are back. So I am back with some examples that I have out of my house to show you exactly how elastic potential energy works. So remember that rubber band that I was talking about? Well, I got one of my scrunchies. So if you pull back this scrunchie, you have elastic potential energy. Then when you release it turns into kinetic energy. Well, then they also tell you in the book that energy can be stored in objects. So if we look at these objects, I have a piece of bread, right? And I have a tennis ball. When I drop the bread, it's not bouncing up. It's not very elastic. But when I take this tennis ball and I drop it, it bounces right up. So it's very elastic compared to the bread. So this is how elastic potential energy can be in objects as well. So that's the end of today, guys. Me and Walter have a lot of planning to do for tomorrow's video, but I just wanted to start off by saying that I miss you guys and I hope you're doing well, and I can't wait for us to get back to school so soon. So have a great day, guys, and make sure that you go on to the documents and do the worksheet that I have for tonight for homework. Bye, guys. Miss ya.